So, hello, my dear friends. How are you all? I hope you all are awesome. So, friends, today we will start a new lecture number 5. Okay. So, I hope you will enjoy this lecture. So, again, this is very important and very interesting lectures. Okay, guys. So, I hope. So, now without wasting the time, let's start it. Yes. So, today we will discuss revisiting rational number and their decimal expansions. Okay. So, before starting the topic, we have to know what is rational number. So in the beginning, okay, we already learned about the rational number. What is rational number? So here we just take a brief discussion about the rational numbers. So what is rational numbers? Yes, a rational numbers is a number in which, okay, a rational number is a number which can be expressed in the form of p upon q, which can be expressed in the form of p upon q. Here p and q are integer and q is not equals to 0. Okay, so I hope you got this point. Now here we will see the decimal representation of rational number. What is? Yeah, the decimal representation of rational numbers. Okay, so now we know that what? Yes, we know that real number real number is of two types. What are they? Yes, rational number. Yes, rational number and irrational number. Now again, rational number are also of two types. What? Yes. First is terminating decimals. What? Terminating decimals. And second is non-terminating and repeating. And repeating. Okay. Yes. And irrational number is also the another type, which is non-terminating and non-repeating. Okay, so I hope you get this point. So real numbers are of two types: rational numbers and irrational numbers. Rational numbers are also two types, terminating decimals and non-terminating decimals and repeating. Okay, and irrational numbers having one part is non-terminating and non-repeating decimals. Okay, so we will see briefly in next slides. Okay, so don't worry. Yes, now let's move on. Yes, our first point is finite or terminating decimals. Listen, terminating decimals are also called finite decimals. Now what are finite or terminating decimals? So every fraction of p upon q, every fraction p upon q can be expressed as a decimals, okay, if the decimal expression of p upon q terminates, means comes to an end, means after the decimal points. Let's suppose we have p upon q. Okay, if we divide p by q, then it will be divides completely, means after decimal points there is a finite digits. Okay, yes, then the decimal so obtained is called terminating decimals. For example, For example, if we have 1 upon 4, if we divide 1 by 4, then the result is 0.25. Now, after the decimal point term, there is a fixed digit, there is a finite digit, which is 2 and 5. Okay, so that's why this is called terminating or finite decimals, because after the points it is terminate, means it is comes to end. Okay, if we take the another example, 5 upon 8, so what's the result is? So the result is 0.625. Same again, after the decimal point there is a fixed digit, which is 6, 2 and 5. Okay, now again, so now this is a mixed fraction, 2 3 upon 5. Now if we solve it, 5 to the 10, and 10 plus 3, 13 upon 5. Okay, now so the result is 2.6. Same again, after the decimal point there is a fixed digit, there is a finite digit, which is 6. So students, I hope you get this point, what is finite or terminating decimals. Okay, so these these numbers can be expressed in the form of terminating decimals. Okay, so now let's move on. Yes, now we have to see what is non-terminating or repeating decimals. Okay, so let's move on. So what is non-terminating? Simple. Non-terminating means there is no termination, means after the decimal points numbers are continuously coming. Okay, yes. Now what is repeating? Repeating means the number after the decimal points, the numbers are continuously repeat. Okay, the numbers are continuously repeats, either these numbers are digits repeatedly, or it may be the set of digits. Okay, so now if you take the examples, for examples are 2 upon 3. If we divide 2 by 3, then we have 0.66666 and so on. So this number, these decimals are also called non-terminating or repeating decimals. Here after the decimal points there is no finite numbers, means there is infinite numbers. Okay, and the numbers are repeating continuously, means we can write it as also 0.6 bar. This bar means the 6 is repeating continuously. Okay, now if we take the another example, 15 upon 7. If we divide 15 upon 7, then we get 2.1428 5 7 1428 5 7 and so on. Here if we observe, after the decimal point same there is no termination, means this is non-terminating, and after the 7, after the point and after the 7 the numbers are continuously repeating, means this number and this number. Okay, so the repetition is starting from, yes, after the 7 number. Okay, so now we can write it as also 2.142857. Now we can write it as this bar. Now we can represent is this. So this bar means this digit 142857 is repeating continuously. Okay, so I hope you get this point. Yes. Now non-terminating or non-repeating decimals. Okay, so if you observe, if we see that finite or terminating decimals, expansion of finite or terminating decimals are rational numbers. I will write here expansion of finite or terminating decimals are rational number, means those numbers are rational numbers. Okay, in this case also expansion, in this case also expansion of non terminating non non terminating and repeating decimals are rational are rational number. Okay, now non terminating or non repeating decimals. So if you talk about this type of decimals, in this case, from this name, non terminating means there is no termination, means after the decimal points the digits are coming to the infinite. Okay, now non repeating decimal means after the decimal points there is no repetition, means if we take the examples like 0.67525312357 and so on, means there is no repetition. If we dividing some numbers, then if we get this result, this means this is non terminating or non repeating. And now the important point is that, so the decimal expansion, so the expansion, so the decimal expansion of, so the decimal expansion of non terminating and non repeating decimal is irrational number. In this case there is a difference, is irrational number. Okay, so I hope you get this point. Now let's go on. Yes, special characteristics of rational numbers. What are the special characteristics of rational numbers? So the first point is that every rational number is expressible either as a terminating decimal or as a repeating decimal. So the first point is very clear. So every rational number can be expressed as in the terms of terminating decimals and non-terminating or repeating decimals. Okay, okay, so the second point is that every terminating decimals is a rational number. Okay, so this is the conversion of this number. So this is the conversion of first characteristics, means every terminating decimals, every terminating decimals is a rational numbers. Okay, so same as that every non-terminating or repeating decimals is a rational number. So this is the conversion of first theorem, first characteristics. Okay, now let's move on. Yes, now conversion of decimals numbers into rational numbers. Now we are converting the decimal numbers into rational numbers in the form of p upon q. So our first case is that if we have to first of all, first case is that the procedure of terminating decimals. This is the procedure of terminating decimal. Now in this case, in this terminating decimals case, okay, we have to convert terminating decimals into p upon q form. Okay, so first of all, we just take the example directly. So first example is that if we have a number 6.225. So first step is that we have to remove this decimal point, and how many digits are comes under the denominator? Yes, 000 means three zeros are comes. Okay, and now the result becomes 6225 divided by 1000. Now if we are simplifying this after reducing after in the simplest form, then the result should be 249 divided by 40. Okay, so this is the simplest form. Okay, so what are these steps? So the steps are, firstly we have to remove the decimal points, and after the decimal points, if you have three digits, so three zeros comes in the denominator. Okay, and after this we have to simplify and convert in the simplest form. And what is the simplest form? So the simplest form is this 249 upon 40. This is our first case. Now second case is that conversion of pure recurring decimals to the form of p upon q. Means in this case we are convert non-terminating or repeating into the p upon q, procedure of non-terminating repeating decimals. Procedure of non-terminating non-terminating decimals means now let's take an example. Okay, so if we have 0.585 bar. Okay, now we have to convert this into the what? Yes, into the p upon q form. So the solution is that let x is equals to 0.585 bar. Bar means the 585 is repeating continuously. Okay, now x is equals to 0.585. 585, we are removing the bar. 585, 585, and so on. Okay, so this is our first equation. Now here we have to multiply. Here we have three repeating digits. Okay, we have three repeating digits after the decimal points. What are these digits? So the digits are 585. Okay, so So we have to multiply both this side by 10 raised to power 3 or 1000. Okay. So in equation 1, we are multiplying x into 1000. Why 1000? Because after the decimal point, there is a 3 digit which is continuously repeating. Okay. Now here is also we are multiplying 0.585 585 585 and so on. So 1000x is equals to 58 multiply 1000, 585.585 585 and so on. Okay. Now this is a second equation. Now subtract both these equation. So so subtracting 1 from 1 from yes 1 from second. Now we get 1000x minus x is equals to 585.585 585 and so on. Okay. Minus 0.585 585 and so on. Now here we get 999 of x is equals to, now this part will be cancelled, so the result is 585. Now what is this x? So our x is 585 divided by triple nine. So this is our result. Okay. So I hope you get this point. Okay. Now let's move on. So this is the method to convert the non-terminating repeating decimals into P upon Q form. Okay. Yes. Now check if a given rational number is terminating or not. Okay. So now we have to check whether the rational number is terminating or not. If A upon B is a rational number, if we have a number A upon B, if we have a number A upon B, okay, then its decimal expansion would terminate. Then its decimal expansion would terminate if both of the following conditions are satisfied. So there are two conditions. If this rational number is this A upon B form satisfying the both the condition, then it is a terminating number. Then it is a terminating number. So now our first condition is that HCF of both the digits, HCF of A and B should always be 1. No problem. Because any of the number in the world, any of the two numbers, the 1 is the common factors. Okay. So HCF of every two numbers is always equals to 1. Now the second condition is most important thing. That is B can be expressed, means the denominator can be expressed as a prime factorization of 2 and 5. If we have we are finding the factors B, and it should be in the form of 2 raised to power n. Okay, 2 raised to power m into 5 raised to power n. Then the result would be terminating. Okay, whether m or n or both can be 0 if the prime factorization of P contains any of the other than number. Okay, if prime factorization contains 7 3 4 5 9 other than this, then the result would be non-terminating. So for terminating decimals, the form B should be expressed in the factors in the factorization in the form of 2 raised to power m into 5 raised to power n. Okay, I hope you get this point. If the prime factorization of B contain any other than 2 or 5, then the decimal expansion of that number will be recurring. Will be, yes, recurring. So now let's just take an example. If we have 1 upon 40 and the result is 0.025. Okay, now this is a terminating decimal. Now if we see that our first condition HCF of 1 or 40 is equals to 1, of course. Now the second condition is that the prime factorization of 40 is what? 2 into 2 into 2 into 5 into 1. Okay, it means 2 raised to power 3 into 5 raised to power 1, and this equation is similar to this in the form of like this. So 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 the number 1 upon 40 is a terminating decimals. Okay, now let's just take another example. Now 3 upon 7, the result is 0.428571 and so on. So the HCF is 1, no problem. Okay, and the denominator having 7, which is other than 2 or m. Okay, so the number is not terminating, this is non-terminating. Okay, so I hope you get this point. So now let's move on. Now we are doing a lot of examples. Okay, yes. So our first question is that without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. We have to tell without long division method that the number is terminating or non-terminating. Okay, so very easy, friends. In previous slides we have learned about this concept. Okay, so how we can do this? Okay, so let's just start. Yes, so the first question is that 13 upon 3125. Okay, what is this? Yes, so now first of all we have to check the prime factorization of the denominator. If the prime factorization of denominator is in the form of 2 raised to power m or 5 raised to power n, then this is terminating. Or if you get another number other than this, then the result would be non-terminating. So the first case, in this first case, the factors of 3 1 2 5 is, what are these factors? 5 into 5 into 5 into 5 into 5. So the result is 5 raised to power 5, and this is what the form, this is of the form of 2 raised to power m and 5 raised to power n. Here what is m? M is 5, and what is n? N is 0. Okay, so this is what, this is terminating decimals. Okay, so the denominator has only 5 as its factors, so it has a terminating decimal expansion. Okay, now in this case we have to do the factors of 4 5 5. What are the factors? So the factors are 5 into 7 into 13. Here The factors are other than the expression 2 raised to power m into 5 raised to power n. So the denominator is not in the form of 2m or 5n. Okay, so it has non-terminating decimal expansion. It has what term? Non-terminating decimal expansion. Okay, now let's move on. Yes, 29 upon 343. Now factorize the denominator. 343. We get what? 7 into 7 means 7 raised to power 3, and this is not in the form of 2 raised to power m, 5 raised to power n. So this is non-terminating non-terminating decimal expansion. Okay, now let's go on. Yeah, 129 upon 2 raised to power 2, 5 raised to power 7, and 7 raised to power 5. So okay, we will directly we can say that this expansion is non-terminating decimal expansion. Non-terminating decimal expansion. This is the short form. Okay. Yeah. No, it's just not a short form. It is. I'm writing here just like as a fun. Yes. So you have to write the full non-terminating decimal expansion. Okay. So now, yes, let's move on. 35 upon 50. So by so 50 is equals to 50 is equals to, if you do the factors, is that now, first of all we have to convert in the simplest form. If we divide, we have 35 upon 50. If we divide 5, this goes to 7 times, this goes to 10 times. This is 7 upon 10. Means we have to find the factorization of 10. We have to find the factorization of what? Yes. So factorization of 10 is 2 into 5, which is of the form of 2 raised to power m and 5 raised to power n, and this is terminating this is what? This is terminating decimal expansion. Okay, so now the next question is 210. So if we divide this, so first of all again we have to convert in the simplest form. What are the simplest form? So the simplest form is that 77 divided by 210. Okay, yes. So this can be written as 7 into 11, and it can be written as 30 into 7. Here 7 has been gone. Now 11 upon 30 is left. Now if we are doing the factors of 30, we get 2 into 3 into 5. Here if you see, 3 is the extra. Okay, so we can say that this is non-terminating decimal expansion. This is non-terminating decimal expansion. Okay, so now let's move on. Yes, write down the decimal expansion of those rational number in question number 1 above which have terminating decimal expansion. Okay, so friend, what we have to do is that, listen, we have to do that the decimal expansion of those rational numbers which have the terminating decimal expansion. So first of all, we have to see this is terminating or non-terminating. If this is terminating decimal expansion, then we have to do this. We have to write down the decimal expansion. Okay. So listen to me very carefully. What are the decimal expansion of 3125? What is this? So the decimal expansion of 3125 is that 5 raised to power 5. Okay. Now we can write it as also 13 upon 5 raised to power 5. Okay. I hope you get this point. Now after this, we have to multiply in both the side in denominator or numerator by 2 raised to power 5. You have to multiply and divide by 2 raised to power 5. Then 13 into 2 raised to power 5, and this will become 10 raised to power 5, because here is base are different and exponent is same, means 5 into 10, 5 into 2 10, and this becomes 10 raised to power 5. Okay, here we are applying the rule of a raised to power x and b raised to power x. If we are multiplying this, if we are multiplying this, here is base are different and exponent is same, then the result is a dot b, means a into b raised to power x. Okay, so here we are doing the same things. Okay, now the result is that, now, so 13 into 2 into 2 into 2 into 2 into 2. Okay, now, and divided by 10 raised to power 5. And so the what is the result? 2 into 2 4, 4 into 2 8, 8 into 2 16, 16 into 32, means 13 into 32 divided by 100, 10 raised to power 5. Okay, so now what is the result? So the result is, if we multiply this, okay, now 32 multiply by 13, we get 2 3s are 6, 3 3s are 9. Okay, 2 and 3, we get 6, 11, 1 carry, and there is 4. It means 4 1 6 divided by 10 raised to power 5, and the result is, what is the result? So 0.00416 means we are converting it into the decimal expansion like this. So this is our result. So friend, this is very simplest form. This is very simplest form, very easy method. Okay, you can do it by the long division method also. By the long division method also. So now, so this is a non-terminating decimal expansion. This is has a non-terminating decimal expansion. Non-terminating decimal. This is non-terminating decimal, so we cannot find the expansion. This is also a non-terminating decimal expansion, and this is also a non-terminating decimal expansion. This is, what is the form? This is 7 upon 10. Okay, so here is directly convert 0.7. Okay, now let's do the another question. Yes, this is, in the previous questions we have seen that, we already seen that this is non-terminating decimal expansion. So now here we are ending this lecture. Okay, so now we will meet in the next lecture. So thank you very much.